Across several sites in Europe, elements of the first Vega-C are being produced, tested and prepared for shipping to Europe's spaceport in Kourou, French Guiana. There, all these elements will be assembled for Vega-C's inaugural flight. Vega-C is the result of excellent collaboration across Europe's space industry, with Avio as prime contractor and ESA overseeing the design and production of this new lightweight launcher. ESA's new Vega-C launcher will be more versatile, cost-effective and powerful, prerequisites to comply with evolving market demands.
So the need to design a new Vega, and with the so-called consolidated version Vega-C, comes from the need and from the wish to provide the European answer to the growing market of small spacecrafts. And in fact, with the new Vega-C, we are able to increase the launch capability to put into orbit nearly 60% of additional mass with respect to the previous Vega, reaching up to 2.3 tons of spacecraft mass.
To lift this increased payload mass, the four-stage Vega-C has two new and more powerful solid rocket motors, the P120C for the first stage and the Zefiro 40 for the second stage. The P120C will also be used as strap-on boosters for the upcoming Ariane 6 launcher, sharing development and production costs between two launchers by using common building blocks. Vega's reignitable upper stage Avom Plus has a liquid-fueled engine and has been designed for extended stays in space. In addition, all interstage segments of the launcher have been redesigned. New avionics and actuators subsystems have been developed, including thrust vector control.
So the thrust vector control systems are the systems that control the thrust of the launcher. The thrust is needed to lift the launcher to space. This thrust vector control system consists of two electromechanical actuators, an electronics, a cable set and a battery set. The battery set delivers the power to the electronics, which is called IPU, Integrated Power and Drive Unit. And this Integrated Power and Drive Unit controls the two electromechanical actuators. These actuators gimbal the nozzle. They are put at 90 degrees, so we can gimbal the nozzle in any direction we want, in order to be able to steer the launcher to its desired trajectory.
These new interstages were redesigned in a way that minimizes costs and limits the assembly processes in Kourou. With a height of 9 meters and a diameter of 3.3 meters, Vega-C's fairing is also larger than the current Vega. This is needed to accommodate larger payloads. Vega-C is also a versatile launcher. It can deliver one large payload up to 2.3 tons into its reference low Earth orbit, but also through a range of adapters, such as the Small Spacecraft Mission Service and others, allows for ride-sharing of two or more payloads in various configurations. ESA is already looking to the future and plans to expand the capabilities of Vega-C even further and to optimize the Vega-C launch services.
In terms of missions, we can really have a broader portfolio of activities. For example, we will launch our first operational reusable vehicle of Europe, Space Rider, which will be launched with Vega-C, then operate a couple of months in low Earth orbit before coming back autonomously on Earth. So with Vega-C, we really have an enhanced opportunity. You also have an enhanced payload volume under the fairing. We have the double with regard to Vega, and this at similar prices that Vega initially, so an enhanced competitivity. So Vega-C will offer new services, competitive services for European institutional needs first, but also global market needs.
With Vega-C, Europe consolidates its position in the global launcher market. European industries once more working together to prove its excellence and reliability. Vega-C offers affordable launches combined with innovative payload versatility, which makes this a competitive launcher. At the same time, Vega-C helps to ensure Europe's independent access to space for years to come.
you.